Take a close look at these 3D prints on my table. All of them have one thing in common. They were generated by AI. In this video, I'll briefly explain how AI 3D model generation works, because understanding the technology makes you better at using it. Then I'll show you how to use it in practice, optimized for FDM 3D printing, and demonstrate how to replicate everyday items from a single picture within seconds. No complex 3D scanning needed. Let's get right into it here at JanTec Engineering. This video is sponsored by Tripo AI. Get 500 bonus credits from my link and use code TRIPOCREW for 60% off your first month of Pro. AI is taking everything by storm right now, and whether you like it or not, I think it's worth understanding how to use these new tools. When it comes to models for 3D printing, AI shows up in two different ways. On one side, there's AI-assisted CAD, tools that support your engineering workflow, help with parametric design, or generate code. On the other side, there is generative 3D model creation. You type in a text prompt or upload a photo, and the AI generates a complete textured 3D model. I come from the CAD world, designing engineering parts, but I really suck at organic modeling used for characters, sculptures, and free forms. That's why today's video is all about the second one, generative 3D AI modeling using Tripo AI, one of the leading providers in this field. But before we open Tripo Studio, let's take a quick look under the hood. Just like understanding slicing makes you better at designing for 3D printing, understanding the generation pipeline makes you better at prompting. I would consider this the nerd section, so feel free to skip ahead if you're only interested in my results. So what actually happens when you hit generate? If you start with a text prompt, the AI doesn't jump straight to 3D. First, a language model cleans up and enriches your prompt. Then, and this is the important part, your text gets turned into an image with a model like NanoBanana Pro. This concept image is what actually drives the 3D generation. From that image, the geometry model takes over. It was trained on millions of 3D objects and has learned what real shapes look like. Your model is generated in a compressed mathematical representation starting from pure noise and refined step by step, guided by the input image. The model learned during training what noise removal steps lead to models matching the image, and at generation time, it runs that learned denoising process. Once the shape is done, an algorithm called Marshing cubes extracts the actual polygon mesh from it. Then retopology cleans up that mesh, and finally an optional texturing stage paints the model from multiple views. If you want to dive deeper into the research behind this, Tripo publishes their papers openly, and I've linked them in the description. We can extract 3 key insights out of this pipeline. First, the AI is good on what it was trained on. Those were mostly single-centered objects, so prompt one object, not a whole scene. Second, the AI guesses what it can see. Give it one photo, and the backside is pure imagination. Give it multiple views, and you constrain that guessing. Third, it optimizes for believability, not for dimensional accuracy. The result looks right, but hitting exact measurements is hard for the AI. So it complements CAD, it doesn't replace it. Know which tool to use for which job. Now let's put the theory into practice. This is Tripo Studio, the web app where everything happens. In the gallery, you can get some inspiration and see what other users have created. To generate models for 3D printing, we click on High Detail Model. In the top left corner, we can choose between Image to Model, Multi-View Images to 3D, Batch Images to 3D, and Text to Model. I'll type in a prompt. Create a cute cartoon-style turtle. Hit Generate, and about 2 minutes later, there it is. A complete textured 3D model matching our description, ready to be 3D printed. But remember the nerd section? My text got turned into an image first. We can control the process of the image generation by clicking on Image. We can put our prompt there, select our preferred generation model, and refine the output by editing the image. When it looks good, we can simply click on Generate 3D and the AI does the rest. You can also upload a photo and Tripo reconstructs the object in 3D. With a single image, the AI has to guess the backside. Sometimes it guesses well, sometimes not so much. That's exactly why there's multi-view input, front, back, left and right. The more views you provide, the less the AI has to imagine, and the closer the results get to the real object. I will share some of my real-life applications of this in the next chapter of the video. Once you have a model, Tripo Studio offers a whole set of refinement tools. Retopology converts the raw, dense mesh into a clean, structured topology, great if you plan to edit the model afterwards. The texture tool lets you regenerate or restyle the surfaces. Part segmentation splits your model into logical pieces, really useful for multi-part or multicolor prints. And there's automatic rigging, if you want to animate a character. Not relevant for 3D printing, but impressive nonetheless. When you are happy with your model, it's time to export. For 3D printing, choose STL. And if you work with game engines or Blender, GLB, OBJ, and FBX are available as well. Which brings us to the last step, slicing. AI-generated models behave a bit differently than your typical CAD exports, so here are a few tips. Tip number 1, AI models come without real-world dimensions. So decide how big your print should be, or measure one feature of the original object, enter that value into a single axis in your slicer, and with uniform scaling enabled, the other two axes follow along automatically. Tip number 2, use the cut tool in your slicer to create a perfectly flat bottom. Generated models rarely sit flush on the build plate. Simply cut a few layers, something like 0.4 or 0.6 mm of the bottom, to achieve a perfectly flat bottom surface. And tip number 3, use organic supports. These models are full of overhangs and curved surfaces, and organic supports are much easier to remove and leave fewer marks. So, what is this actually good for? Over the past weeks, I generated and printed a whole range of examples. First, cosplay props. I generated a sci-fi handheld scanner and printed it. Here's the digital model and the printed part side by side. This is the bridge from the computer into the real world and exactly where AI generation shines. Organic, decorative shapes that would take hours to sculpt manually. It is also pretty good for toys. Children can put their drawings in it and receive a full 3D model for 3D printing. In a more technical context, I see potential for product design concepts. Quick visual prototypes to communicate an idea before committing to hours of CAD work. But my favorite use case is this one: replacing a 3D scanner. I found this old wooden chess set. I love playing chess and already tried printing different models I found online, but the pieces I have right now are a bit too boring for me. So I took a quick photo of this knight and gave it into Tripo AI. The output 3D model was really good, so I set up a little photo station and took photos from all 4 sides of each piece, uploaded them into Tripo Studio, and within a few minutes I had fully digital versions of my chess pieces. Then I sliced and printed them on my Prusa MK4S. By the way, thanks to Prusa Research for sponsoring my studio and for providing the printers and filaments for these videos. The details are really good. The scale is right, and you can even see the small imperfections like the broken corners of the knight's head. Compared to a proper 3D scanner, this is dramatically cheaper and faster. Of course, it's not 100% dimensionally exact, but to replace a lost pawn or preserve the shape of an object, it's more than good enough. I use Tripo's latest HD model, H3.1. It promises to generate high-fidelity models with denser geometry, enhanced detail, improved texture clarity, and refined geometric accuracy. That gave me the confidence to try even more complex models like this statue I randomly photographed in Japan, or whole monuments. And honestly, I'm surprised how well these came out. Now, to be fully honest, this is not the right tool for engineering parts. If you need exact dimensions, tolerances, and surfaces, that remains CAD territory. The AI optimizes for looks, not for measurements, but that's fine. It's a different tool for a different job. Overall, I'm really happy with my generations and honestly surprised by the high quality. I think 3D model AI generation is a powerful tool. It can boost your workflow, bring ideas to life that you could never model by hand, and for some everyday cases, even replace a 3D scanner. AI 3D generation is still in an early phase, and I'm sure there's much more to come. So I'll keep a close eye on Tripo's new features. Have you ever used AI 3D generation? And what did you make? Let us know in the comments. If you want to try Tripo AI yourself, use the first link in the description. You'll get 500 bonus credits for free. Thanks to Tripo AI for sponsoring this video. This enables me to make all the videos on my channel. And as always, thanks to my channel members for your support, and see you in the next video here at JanTec Engineering.